Hello, welcome back. And this time we are gonna learn some interesting concepts. And you can see here in our diagram that our services has changed a little bit. And now we have a kind of protection in which service. And that is because we are going to start to introduce a concept of cars, right? And so basically when you are managing, as you are an architect of a system or in a company, you'll have to apply some security measures, and then every service should be following, right? But however, in a company, service can be used in different languages, and sometimes you don't have access to what each team is doing. So that's why you should be taking security measure in a centralized way and in a way that all the other teams can just leverage from what you have been doing. And there is this concept of sidecars, which it is something that it became very popular with Kubernetes. But you don't need necessarily have Kubernetes to implement that. You can implement that in any system. And the concept of sidecar, it is just a design pattern that abstracts certain features such as inter-service communication, monitoring, and security. And here it is the keyword that we want to focus, right? On the security side, we want to leverage this design pattern, service sidecar, to perform security measure. And you're gonna see how you're gonna do that. So we can use for many other things, right? So communication, for example, could be applying some health check, some what else? So circuit breakers and retries and many other things that you could be doing using this pattern. And this is very common on the service mesh. That's the service mesh architecture, and along with Istio, for example, and Kubernetes in general. So let's just zoom a little bit on what we're talking here. We have our service app, which is developed in Java, let's say, or JavaScript. And you have SensiB, that it can be the same language or another language, right? So you would have to go into each application and try to apply this TLS connections or secure connection between multiple services. And instead of having to do that in each service, you can do once in a sidecar, which will be a kind of process that will be responsible to receive all the requests before reach the end service. And then all this handshake or security measures would be performed on the single place, and you can just distribute this across all the services. And you're gonna see how to do that. So basically, we'll be configuring sidecar proxies using Nginx to establish secure communication and do a handshake between the caller and the receiver. And this will gonna be checking if the service it is HTTPS, and you need to ensure that this service you need to confirm the identity of the server using the certificate, and the same way the server, you'd confirm the request identity using certificate as well. And you're gonna see how you do all that in a simple way. So let's dive into the code. The first thing I have created another Nginx sidecar configuration here. We had before up to now working authn, and now we have a new one. And it is basically the same in the beginning here. We are using our JS path and some simple configuration. We have here the redirect as well of our HTTP into HTTPS, and you have set up here our SSL service, and we have here our certificate. And now and here we have some more configuration about SSL. I think this is not required yet. Remove this. And then I have a service here that I'm using to simulate that it's the app service, right? So this would be our proxy, sidecar proxy, and this would be our app servers. And currently we are applying some, make sure to provide a HTTPS connection, and we are proxying to our service in a HTTP manner. The same way we exemplified here. This connection here would be using HTTPS, using TLS, and then, but inside the process itself, you can just communicate using simple HTTP, because this would be on the same host, right? So not going to outside and using the network for that. So it's safe to just leave a HTTP. This is basically what I'm doing here. So I think that's all I can kind of share for now. Let's just, okay. Another thing that I want to show is that you have started a new service, self-CA here, and you have self-CA local using Nginx, and you have exposed the port 8443, and we have our certificate here, and you are using our Nginx Sidecar configurations. The only difference from what you had before, that you are using this new Sidecar config instead of the auth and configuration. So let's start it. Let's see how it goes. Okay, yeah, both are up and running, and now we want to establish some connections from, I'm going to use it here, the Docker, and I have my containers here, and I will get into the n, right? And I will try to execute a curl to HTTP service a local, and you can see that you are redirecting to the HTTPS, right? So it's saying that you should have HTTPS, and then you see you got the following mentions from the curl. Curl is saying, says SSL certificate problem, unable to get local issue certificate. So curl failed to verify. So the curl failed to verify the legitimacy of the server, and therefore could not establish a secure connection to it. So the curl is requiring that we actually identify the server identity. It is not recognizing this server that you are calling. So basically, we are on the server, and I think this one, we are here and trying to reach this guy. And even though you are calling HTTPS and you're supposed to redirect to the service app itself, it is responding from here, the curl in this case, it's saying that it needs to verify the identity of this server, and it's not able to. It's similar to what you had on our browser when you couldn't identify the server here. So how to fix this? There is two ways. One, it is to say call insert here, and that's then responding. Our response from a security service. You can say that you want to ignore that. That's basically what you did in our browser, and but that's not the best way. The correct way, it is actually to provide the certificate authority as part of the curl command. And when you provide the certificate authority, curl will try to use our certificate authority to validate the certificate that the self-CA it is returning. And then when you do that, it goes perfectly, because now curl, the command curl, it's able to verify the legitimacy of the server certificate that it was given, and it's part of the response, or it's part of the communication. So that shows that you are now connecting to the service-A through the Nginx proxy, and it's done through a HTTPS connection, and we using our certificate authority, we can recognize that certificate that the server is returning. So in the next lesson, we will going to make sure our server also check for the client that it's calling and performing the request. So here we just did a client. The client, it is trying to verify the identity of the server, but we need to also do here on our service that's receiving the call, verify the identity of who it's calling, because we only accept calls from the services that we can verify the identity. And how we verify the identity, it is using the certificate authority certificate. Okay, I hope that made sense. See you in the next lecture.